In this video, we're going to learn how to rationalize a denominator. Rationalize. Rationalize a denominator. What we mean by that is, let's say we have a fraction that has a non-rational denominator. The simplest one I can think of is 1 over the square root of 2. So to rationalize this denominator, we're going to just re-represent this number in some way that does not have an irrational number in the denominator. Now, the first question you might ask is, Sal, why do we care? Why must we rationalize denominators? And you don't have to rationalize them, but I think the reason why this is in many algebra classes and why many teachers want you to is it gets the numbers into a common format. And I also think that I've been told that back in the day before we had calculators that some forms of computation, people found it easier to have a rational number in the denominator. I don't know if that's true or not. And then the other reason is just for aesthetics. Some people say, I don't know, I don't like saying what 1 square root of tooth is. I don't even know. I want to know how big the pie is. So I want a denominator to be a rational number. So with that said, let's learn how to rationalize it. So the simple way, if you just have a simple irrational number in the denominator just like that, you can just multiply the numerator and the denominator by that irrational number over that irrational number. Now, this is clearly just 1. Anything over anything, or anything over that same thing, is going to be 1. So we're not fundamentally changing the number. We're just changing how we represent it. So what's this going to be equal to? The numerator is going to be 1 times the square root of 2, which is the square root of 2. The denominator is going to be the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is 2. That is 2, right? That, by definition, this squared must be equal to 2. And we are squaring it. We're multiplying it by itself. So that is equal to 2. We have rationalized the denominator. We haven't gotten rid of the radical sign, but we've brought it to the numerator. And now in the denominator, we have a rational number. And you could say, hey, now I have square root of 2 halves. It's easier to say even. So maybe that's another justification for rationalizing this denominator. Let's do a couple more examples. Let's say I had 7 over the square root of 15. So the first thing I'd want to do is just simplify this radical right here. Let's see, square root of 15. 15 is 3 times 5. Neither of those are perfect squares. So actually, this is about as simple as I'm going to get. So just like we did here, let's multiply this times the square root of 15 over the square root of 15. And so this is going to be equal to 7 times the square root of 15. Just multiply the numerators over square root of 15 times the square root of 15. That's 15. So once again, we have rationalized the denominator. This is now a rational number. We essentially got the radical up on the top, or we got the irrational number up on the numerator. We haven't changed the number. We just changed how we are representing it. Now, let's take it up one more level. What happens if we have something like 12 over 2 minus the square root of 5? So in this situation, we actually have a binomial in the denominator. And this binomial contains an irrational number. I can't do the trick here. If I multiply this by square root of 5 over square root of 5, I'm still going to have an irrational denominator. Let me just show you. Just to show you it won't work. If I multiply this square root of 5 over square root of 5, the numerator is going to be 12 times the square root of 5. The denominator, we have to distribute this, is going to be 2 times the square root of 5 minus the square root of 5 times the square root of 5, which is 5. So you see, in this situation, it didn't help us. Because the square root of 5, although this part became rational, became a 5, this part became irrational, 2 times the square root of 5. So this is not what you want to do, where you have a binomial that contains an irrational number in the denominator. What you do here is use our skills when it comes to difference of squares. So let's just take a little side here. We learned a long time ago, well, not that long ago, that if you had 2 minus the square root of 5, and you multiply that by 2 plus the square root of 5, what will this get you? Now, you might remember, and if you don't recognize this immediately, this is the exact same pattern as a minus b times a plus b, right? A minus b times a plus b, which we've seen several videos ago is a squared minus b squared. A little bit of a review. This is a times a, which is a squared. A times b, which is AB, minus b times a, which is minus ab, and then negative b times positive b, negative b squared. These cancel out, and you're just left with a squared minus b squared. So 2 minus the square root of 5 times 2 plus the square root of 5 is going to be equal to 2 squared, which is 4. Let me write it that way. It's going to be equal to 2 squared minus square root of 5 squared, which is just 5. So this would just be equal to 4 minus 5, or negative 1. So if you multiply it by, if you take advantage of the difference of squares of binomials, or the factoring difference of squares, however you want to view it, then you can rationalize this denominator. So let's do that. So if I have, let me rewrite the problem, 12 over 2 minus the square root of 5. In this situation, I just multiply the numerator and the denominator by 2 plus the square root of 5 over 2 plus the square root of 5. Once again, I'm just multiplying the number by 1. So I'm not changing the fundamental number. I'm just changing how we represent it. So the numerator is going to become 12 times 2, which is 24, plus 12 times the square root of 5, plus 12 times the square root of 5. All of that over once again, this is like a factored difference of squares. So this is going to be 2. This is going to be equal to 2 squared, which is going to be exactly equal to that, which is 4 minus 1, or we could just 4 minus 5, right? It's 2 squared minus square root of 5 squared. So it's 4 minus 5. Or we could just write that as minus 1, or negative 1. Or we could put a 1 there and put a negative sign out in front. And then no point in even putting a 1 in the denominator. We could just say that this is equal to negative 24 minus 12 square roots of 5. So in this case, it kind of did simplify it as well. It wasn't just for the sake of rationalizing. It actually made it look a little bit better. And I don't know if I mentioned at the beginning, this is good because it's not obvious. If you and I are both trying to build a rocket and you get this as your answer, and I get this as my answer, this isn't obvious, at least to me, just by looking at that they're the same number. But if we agree to always rationalize our denominators, we're like, oh, great, we got the same number. Now we're ready to send our rocket to Mars. Let's do one more of these right here. Let's do one more. Let's say I have, let's do one with variables in it. So let's say we have 5y over 2 times the square root of y minus 5. So we're going to do this exact same process. We have a binomial with the irrational denominator. It might be irrational. We don't know what y is, but y can take on any value. So at points, it's going to be irrational. So we really just don't want a radical in the denominator. So what is this going to be equal to? Well, let's just multiply the numerator and the denominator by 2 times this 2 square roots of y plus 5 over 2 square roots of y plus 5. This is just 1. We are not changing the number. We're just multiplying it by 1. So let's start with the denominator. What is the denominator going to be equal to? The denominator is going to be equal to this squared. It's, once again, just a difference of squared. So it's going to be 2 times the square root of y squared minus 5 squared. Right? If you factor this, you would get 2 square roots of y plus 5 times 2 square roots of y minus 5. This is a difference of squares. And then our numerator is 5y times 2 square roots of y. So it would be 10, and this is y to the first power. This is y to the half power. We could write y square roots of y, 10y square roots of y. Or we could write this as y to the 3/2 power, or 1.5 power, however you want to view it. And then finally, 5y times 5 is plus 25y. And we can simplify this further. So what is our denominator going to be equal to? We're going to have 2 squared, which is 4. Square root of y squared is y, right? 4y. And then minus 25. Minus 25. And our numerator over here is, we could even write this. We could keep it exactly the way we've written it here. We could factor out a y. There's all sorts of things we could do it. But just to keep things simple, we could just leave that as 10. Let me just write it different. I could write that as, this is y to the first, this is y to the 1/2 power. I could write that as even y to the 3/2 if I want. I could write that as y to the 1/2 if I want. Or I could write that as 10y times the square root of y. All of those are equivalent, plus 25y. Anyway, hopefully you found this rationalizing the denominator interesting.